So, again, thanks everyone for coming and attending this National AGI Hub seminar. The topic of today's talk is service-oriented evolution of modern AI. And before starting, I just want to introduce our today's speaker. We have with us Dr. Zhang Li. He is currently a lecturer at Queen's University, Belfast. Before that, he was also assistant professor at Department of Computer Science at University of Concepcion, Chile. He has his PhD and MPhil from ANU, Australia National University, and University of New South Wales, both from Australia. He was also visiting research fellow with the Software Institute of Nanjing University, China. His main research interest is in analytics, big data analytics, edge cloud computing, empirical software engineering, and performance engineering. And I again like to welcome Dr. Zhang Li to start his talk.
Okay, thank you very much, Steph. Thank you for joining this webinar. Actually, this talk is based on our recent position paper, The Service-Oriented Evolution of Modern AI. Well, I should move. Well, actually, there have been extensive discussions about the evolution of AI. For example, we can frequently see the summary of the AI history. That's mainly about the evolution path of AI, okay? Highlighting the milestone technologies, products along a timeline. And some other discussions about evolution of AI may highlight the kind of future predictions, also giving kind of milestone, of course, the predicted milestone technologies or products along the future timeline, right? But none of them mention or gave an irregular pattern behind those, no matter historical view or future view, evolution path. So we are wondering if there's any regular pattern behind the evolution path of AI. If yes, just think about Moore's law. Even such a kind of superficial regular pattern in the evolution of semiconductor industry, there can be various benefits ranging from the company's risk return analysis to government's policymaking, right? So do we also have, or can we also identify some regular patterns behind the AI evolution? Well, I give our position. Yes. And we believe, or at least we identified, let's say, there's a service-oriented pattern behind at least the recent AI waves. And we claim that what's happening in the AI domain right now has happened before in the software engineering domain. Okay. I would say this is the main takeaway from this webinar. The rest of the talk will be just explaining and justifying our position and you know this service-oriented regular pattern evolution regular pattern. Okay. So first of all, let's review. Let's have a very quick review about the service-oriented evolution in the software engineering community. We start from the the definition, the concept, let's say, the normal service concept. In our normal life, the service concept in the software engineering context is exactly the same with the service concept in our normal life we are experiencing every day. For example, we go to the supermarket, we receive services from the staff or even some service carried by those products. We go to the restaurant, we receive service from the chef, from the waiters, waitress. Okay, we go to the bank. Okay, we receive service from the banking staff as well. So by definition, in general, well, service is defined as an interactive process of doing something valuable for someone. And don't forget the interactive process is the critical characteristics of the service concept here. So in the software engineering context, firstly, let's look at the business functionality level. At this level, I mean, the software engineering community introduced the service concept when the software community was facing the software silo problems. It was about at the it was in the very late. I mean, the service concept emerged. Software service concept emerged in the very late 1990s. Led the service-oriented movement was led by a group of companies led by IBM. I clearly remember that. So at that moment, I mean, the software world was facing the software silo problems, challenges. We had quite as many successful software products to use, but they are software silos. For example, we had a flight booking systems. We had a hotel booking systems. We also had a car rental systems, but all of them are separated. And when we try to go, let's say, traveling. Well, we need to book flights, hotels, and rent cars separately by going to different systems. Okay. Then how do we fix this? The service-oriented architecture was introduced to fix this, to address this situation. Imagine we wrap up those software silos into services and give them standardized APIs. Then we will be able to we can create even new business opportunities by using the relevant services by building up a service ecosystem, okay, to create value-added new service systems. For example, in this case, we can claim we are a new sort of travel agency system can be created based on those software silos, previous software silos. Okay, just like Expedia. You see, we can just use Expedia to book flights, hotel, and rent cars all at once, all in one place, let's say. Okay, so still there. So we claim we have the service-oriented business then. But don't forget, behind those services at the previous call screen level, those previously defined software silos may still have monolithic software architecture. And the software engineers, although the customers may feel more convenient than before, the software engineers may still face the same difficulties, the same engineering challenges. Okay, due to the monolithic architecture, right? So how do we do this? I mean, the monolithic architecture will bring challenges into the software maintenance, and there will be challenges in upgrading systems, maintaining the systems, things like that. So how do we fix this then? Well, how about we build up the simple functionality level services? Okay. Just like Netflix did at the beginning. Okay. When by definition, the Netflix, it was, well, at least the community considered Netflix was the first successful company that practiced this so-called Microsoft architecture. Okay, on the Netflix systems interface, every single thing comes from a separate service. Sounds crazy, but it's been proved very successful and it's been employed by widely by many successful companies. Actually, these are already old records. I remember a couple of years ago, Uber claimed its system was composed of more than 4,000 microservices. Okay, it's been widely accepted. So, what about the AI domain? We believe there's also the service-oriented evolution trend across the most recent three AI waves. You see, this is also kind of evolution path from the community's definition. All right, there are three waves in the recent in terms of the modern AI. We have the predictive AI, we have generative AI. Then nowadays, agentic AI is more and more popular. We don't have to go through those text descriptions. We can just look at how they work. We look at the characteristics of their workflow to see their service characteristics. For example, in terms of the predictive AI, well, how it works. Well, we can deploy some predictive AI algorithms and try to feed um, accumulated data or some online data into those predictive AI systems, algorithms. Then we will be able to receive the prediction or continuous or online prediction from the AI systems. But it will still be up to the human beings to decide should we just do something based on the prediction or we just skip it or we don't trust the prediction. It's okay. So although we can still consider the predictive AI is doing something valuable for someone, for human beings, but there's a lack of interactive process. Don't forget the interactive process is a very critical and essential characteristic for defining service. Okay. So let's agree with this. For predictive AI, we don't see much um, a service characteristic. Okay. But what about the generative AI? There's a clearer interactive process when end users use generative AI to do something. Think about how we use ChatGPT, right? We can gradually update our prompts and give feedback to the large language models to receive better and better, hopefully, um, answers, generated contents to answer our questions, to do something useful for us, okay, to give us some suggestions or generated contents. Nowadays, pictures, videos will be no problem then. Okay. So we can see some service characteristics here. And for agentic AI, well, we can even see a service ecosystem, just like the service-oriented architecture in the software engineering domain. See, for the agentic AI, for an agentic AI system, there might be multiple AI agents, not just one. And even if we focus on one single AI agent, maybe there are multiple tools, external tools the AI agent can be using to for taking actions, right? So in that case, we can also, let's say, if we wrap up those external tools into services or microservices or function as a services, we can still imagine it as a service ecosystem, even for a single AI agent. We will mention this later. But anyway, generally speaking, the agentic AI systems can be viewed as a service ecosystem. So we can see we can see clearer and clearer service features and characteristics along these three AI waves. And before we move on, we can even compare, since we are talking about ecosystems, we can even try to find we try to find some common service characteristics between this service ecosystem in the context of software engineering, SOA, and the agentic AI context. Let's recall the service characteristics in SOA. You see the definitions, it's already defined as software agents. Well, we can claim this as just a coincidence, but let's pay attention to the other kind of definitions. The service is encapsulated business functionality at the business level, and we should have, especially this one, the right-hand one, we should define standardized interfaces and even contract to facilitate accessing those services through the internet. Okay, so let's keep this in mind, and we will use them a little bit later. So now let's look at the second wave, focus on the second wave, which is the generative AI We can even see further characteristics in terms of microservice architecture. Because in the generative AI, we can roughly distinguish between the general purpose LLM and purpose-built LLM. For the general purpose LLM, there's a strong monolithic feature in it. But for the domain-specific or purpose-built LLM, we can clearly see a so-called single responsibility principle, which is also a kind of principle for microservices, right? Do one thing and do it very well. And in practice, actually, we use purpose-built LLM a lot. For example, we build banking-focused LLM, we build insurance-focused LLM to address domain-specific requirements. Okay, so really, we see clear microservice characteristics in this case. What about the third wave, the third AI wave? We still see some um, service features, especially in terms of the service ecosystem. We just mentioned actually a little bit, because in this, I mean, I want to reuse this from the community because, I mean, from the AI community, they already identified this is architectural evolution from a single agent, from the agent's view, let's say, to the system's view. Because in this case, we claim, well, agentic AI systems should have multiple AI agents. We are building a agent system, agent ecosystem. But we can also, if we use the service view, well, it matches the service ecosystem view of SOA a lot. And here we also argue that even if we focus on the left-hand AI agents, even if we focus on a single AI agent, we can still imagine a service ecosystem for it or in it, as long as we imagine those external tools as services. Okay, and it's technically doable. Think about the frequently employed examples. Let's say the agents can use calculators, can use search engines, right? All kinds of tools, online tools. Now, how about we just wrap up those tools as function as a service, a calculator function as a service? Then it will be a service ecosystem for the single AI agents as well, right? So still SOA. Then what's the benefits? What's the benefits of such a regular pattern, right? So why do we have the benefit? Why do we want to have the regular patterns behind those evolution paths? Well, just like Moore's law, all right, and even more than that. At least in this case, we identify roughly two main benefits in this case. The first one would be identifying the misdirections, mistakes, wrong research in the existing AI research and development. For example, I don't want to set it because we are trying to criticize it, right? It's actually one of the not one of them, but it's a very highly cited paper. The researchers realize that the AI community or the AI systems are facing the increasing amount of ever-changing APIs. Then they proposed to use a fine-tuned model, machine learning techniques to adapt those ever-changing APIs. But following the lessons, by referring to the lessons we have learned from the software engineering domain, service-oriented architecture in specific, this is absolutely wrong. If we imagine these ever-changing APIs to represent those software silos, okay, and we want those software silos to work together to cooperate with each other. we shouldn't just use another kind of fine-tuned models to adapt with them. Instead, we should standardize their APIs. We wrap up their into APIs. We have APIs, which is good. We should standardize. Let's recall the definition of SOA, services in the SOA context, right? The right-hand definition, remember? We standardize the APIs. We develop contract mutually, widely standardized contracts to facilitate accessing these services through internet. Okay, here should be the same. We should focus on the standardization instead of adaptation. Okay, so by the way, our community is doing, I mean, the AI community is doing the same, doing the right thing now. Okay, I would like to mention that we came up with our position last year, and these protocols contracts, at least were announced this year. All right. So I want to justify that apparently this is the right direction. This matches the previously learned lesson in the software engineering community. Okay. And we believe, at least in our opinion, that research that uses fine-tuned models to adapt those ever-changing APIs was wrong. Okay. So this is the first benefit, identify mistakes, identify the wrong research. Another benefit would be revealing the future research directions, revealing the insightful agenda for the future AI research and development. For example, uh, we can consider constructing function as a service backbones of deep learning workflows to target the serverless AI agents. Okay, at least has this is something um, the software engineering community has done successfully. Okay, maybe it's worth borrowing such experiences from the software engineering community. Okay, so quick conclusions. Firstly, let me repeat what's happening. This is part of our position. It's also a conclusion that what's happening in the AI domain has happened before in the software engineering domain. And it'll be worth reusing this software engineering, especially software engineering knowledge, especially software architecture knowledge, to evolve the architecture of AI technologies. You don't have to agree with us. These are our potential conclusions. Essentially, as I mentioned, they are essentially our positions instead of technical conclusions. You don't have to agree with this, but please agree with our motive behind our position. I mean, identifying regular patterns behind the evolution path of AI instead of just simply listing those milestones, the milestone technologies, products along the timeline. Because it's the regular pattern that would be way more um, valuable and helpful to guide our future research and development of AI. Okay, so thank you very much, and it's a relatively short webinar because I feel like I must fall asleep. So sorry
No,
about that.
thanks,
Thank you very
Zen.
much.
That was really nice.